All right, here's page 2 of the 5.3 notes. So we learned in the last video that if we have all even vertices, we're guaranteed to have an Euler circuit. If we have exactly one odd pair, we have an Euler path, and this is assuming we have a connected graph. So if we're given this graph, what we need to do is determine the degree of all the vertices. So notice on the corners I have 2 lines coming off. So all of those will have degree 2. Now here in the middle I have 1, 2, 3, 4. And I can see the same pattern all the way around. So all of these are going to be 4s. Now on the inside, if I look at this one, it is 1, 2, 3, 4. And again, we have the same pattern all the way around there. All right, so this one is all even vertices. So what we can conclude from that is that we do have an Euler circuit. So we're going to conclude A. And on your homework, I have you explain why. So we would say we have an Euler circuit because we have all even vertices. All right, so let's try B. Notice the ends. They have 2 lines, so they're degree 2. Coming down here, I have 1, 2, 3. And then that's going to be the same all the way around. Now I can keep going, but as soon as I see an odd, I know that I can't have an Euler circuit. Now remember, an Euler path can have only one pair of odds, and I'm already up to 2 pairs of odds. So I can stop here and conclude this is C, which is neither. And my justification would be that I have more than 2 odd vertices. All right, so continuing with our next examples. So if I start with these corners, these are all going to be 2s. I'm going to do that all the way around. Now if I look at this piece in the middle, I see 1, 2, 3. But notice this one's not exactly like it because it has an extra line, so it's 1, 2, 3, 4. Continuing around, I see 1, 2, 3. This one's 1, 2. This one is 1, 2, 3, 4. And this one is 1, 2, 3. So at this point I have 3 odds. I can keep going if I want, but it looks like I've got too many odds. So this is just like the previous problem. I'm going to say C, which is neither, because I have more than 2 odd vertices. All right, so looking at B, well, there's all kinds of things here. So let's start with the corners. These are going to be 2s all the way around. Then here I have 1, 2, 3, 4. And it looks like that's going to be the same all the way around. 1, 2, 3, 4. Okay, so 4s all the way around there. Now if I work into the middle here, I have 1, 2, 3, 4. So all of these are also going to be 4s. Now notice in the very center, you may be tempted to count that, but there's no dot there, so that's not a vertice. So if I count all those or look at them, I can see that they're all even, and that means that I have an Euler circuit because I have all even vertices. All right, our last two just have descriptions but no picture. B says a disconnected graph with 6 vertices, all of degree 2. So they're all even, but notice the word disconnected. Remember, our graph does have to be connected. So this is neither. And my justification would be the graph is disconnected. And my last one says a graph with 12 vertices, all of degree 3. So that is going to be too many odds. So that one's also a neither. Remember, if I have exactly 2 odds, then I have an Euler path. So we didn't see an example of that. We didn't see a B on here. But if I have more than 2, it's a neither. So I'm just going to say more than 2 odd vertices. Now on the next page you're going to see a graph that we did in the last section. So we took the Königsberg Bridge problem from 5.1 and in 5.2 we changed it into a graph. So remember the idea was that you had a north and south bank and then you had 2 islands with a total of 7 bridges. So these are your 7 bridges. And the townspeople wanted to know, is it possible to cross every bridge once and only once? So really what they were asking is, was there an Euler path or an Euler circuit? So if you started and ended at the same place, it'd be a circuit. If you could end somewhere else, it would be a path. So we can answer that now. We just need to count the degrees. So here's a 3. Here's a 1, 2, 3, 4, 5. Here's a 1, 2, 3. And here's a 1, 2, 3. So we can see that all of our vertices are odd. So what that tells us is there's no Euler path, because that would be exactly 2 odds, or circuit, because that would be all evens. So basically what the townspeople eventually found out is that it is impossible to cross every bridge once and only once. In your videos here, I put a little YouTube video that has way better graphics than anything I can do. So if you'll watch that video, it gives you a nice overview of these Euler paths and circuits. And it also gives you a better visual on the Königsberg Bridge problem.